to talk about curve sketching. Or actually, we're going to do curve sketching. Curve sketching for polynomials. Suppose you were asked to graph or sketch f of x is equal to x squared minus 4x plus 4. Suppose you were asked to do that. The first thing you should do is take the derivative, which is 2x minus 4. The second step is to factor. This is 2 times x minus 2. That 2 I wrote, it's not there. The third step is to say when it equals 0. It equals 0 when one of those factors is 0. The first factor is never 0. The second factor is equal to 0 at 2. The next thing we do is we find the y value. 2 squared is 4. 4 times 4 is 16. 4 times 2, is 8. Plus 4. It turns out y is 0. Okay, now we do the same exact 4 steps for the second derivative. That is, we'll call it 1 prime, 2 prime. 1 prime is to find the second derivative. The second derivative is the derivative of f prime of x. It's 2. Okay, 2 prime says to factor the 2. Well, it is. And 3 prime is to say when it equals 0. It equals 0 never. 2 is never 0. And 4 prime is to find the y value for this non-existing 0. Okay, so that's done. Their next step, we'll call it 5, is to find their y-intercept. Y-intercept. That means x is 0. Well, if x is 0, then y is 4. Okay, and then the sixth step is to find all the x values from 3 and 3 prime. And there's only one of them. It's 2. And you write it in increasing order. It's 2. And then you make up your table. The only difference now is we're going to write down one column for f prime and another column for f double prime. 2 is the only number. So here's our f prime and f double prime. And the intervals are from negative infinity to 2, and then from 2 to positive infinity. There's only 2 intervals. Alright, now you should look at the faceted versions of the derivative. The faceted versions are here and here. 2 and 2 prime. The first derivative we're going to talk about. 2, the first factor is always positive. 2 is always positive. The second factor is positive if x is more than 2. But that's exactly what that is, more than 2. The other one's negative. So the first derivative is negative on this interval, and it's positive on the other interval. Now, since the first derivative tells you slopes, first the slope is negative, and then it's positive. So we know we have a minute 2. Now let's look at the second derivative. The second derivative is 2. It's always 2. That is, it's always positive. Since there's no change in the second derivative, there is no point of inflection. Okay. We know just one point, well, we have a few points. we know 2, 0. 2, 0 came up. That's right here. And we know that the y-intercept is at 4. 1, 2, 3, 4. That's the y-intercept. Okay. Now, what we need to do is draw the graph just using the first derivative. And there's a 4 there. Between negative infinity and 2, the slope is negative. It's coming down like this. And then after 2, down to 2, excuse me. And after 2, the slopes are positive. So I'm going up. It's increasing. It's increasing. First, it was negative. That means decreasing. And then it's increasing. And the concavity is always positive. That's the second derivative. Since it's a plus here, on our interval, it's some portion of this. On this interval, since it's positive, it's some portion of that. That is, the graph looks just like this. There it is. There it is. A nice quadratic. For the record, if you factored this, you would realize it's x minus 2 squared. So instead of going to 0, 0, and drawing a nice parabola, you go over 2 to the right, and you draw a nice parabola. Make sure you cross that good old 4. That's a quadratic. Let's look at a cubic. We'll do a cubic, a 4th degree, and then we'll come back to cubic, and I'll show you a nice little formula that really eats through these problems. You never have to take derivatives or anything. Suppose we were told the y, or f of x, y is equal to x to the 4th minus 12x cubed plus 48x squared minus 64x. And you are asked to sketch this graph. So you do the same 6 steps. Some of them get repeated. The first step is to find the derivative. 4x cubed minus 36x squared plus 96x minus 64. Next step is to factor. You can factor out 4, you get x cubed minus 9x squared plus 24, I guess. 24x minus 16. And then, you see, you have to try to factor this. I would always try 1 and negative 1. When you try 1, remember, 1 to any power is always 1. 1 to any power is 1. It is just write down the coefficients. And it turns out that that's 0. Why? Because 1 plus 24 is 25. If you take away 9 and you take away 16, you took away 25, which is 0. So we know that 1 is a 0. We know that. And they're going to, what we're doing here is completely pre-calculus. You have to know how to find zeros of a polynomial. If 1 is a 0, then x minus 1 must be a factor. That is x cubed minus 9x squared plus 24x minus 16 must contain a factor of x minus 1. But let's just say for a moment that it did. That is, when you factored this cubic, however many factors you got x minus a number other than 1. X minus a number other than 1. maybe x minus 4 or x minus negative 2, which is x plus 2. Let's suppose you did not get x minus 1. Well, remember, for example, when you do factor it, if you put 5 in for x and you got 80, well then when you put 5 in for x up here, you must also get 80. They are equal. For example, a moment ago, I said that this equals x minus 2 squared. Well, if somebody asked me what I get when I put 5 in here, I wouldn't put 5 in there. I put 5 in here. They're equal. 5 minus 2 is 3. Square the 3, get 9. You want to do 5 squared minus 4, 5. That's 5 plus 4 and get 9. Fine. But they're equal. You have to have a good command on what equal means. Now, suppose when you factor this x cubed function, you did not get any factors that were x minus 1. But there's a problem there, because when you plug in 1 for x here, you get 0. When you plug 1 in down here, you get 1 minus not 0, not 1. You get 1 minus not 1 times 1 minus not 1 times 1 minus not 1. Well, this is not 0, this is not 0, and this is not 0. Because only 1 minus 1 is a 0, and if the number in here is not 1, you don't get 0. The problem is when you multiply those numbers, you don't get 0. And that's the problem, because the top one gave us 0. X minus 1 must be a factor. If 1 is a 0, x minus 1 must be a factor. The question is, what's the other factor? But that's a division problem. If somebody asks you, 10 is equal to 2 times what? That's the division problem. Do 2 into 10, get your answer. We need to do x minus 1 into this polynomial. And I'll do it one time for review, or by my RP Calc video. But I'll do one of them. You can also do synthetic division if you prefer. What makes this 0 is 1. What goes here is the coefficients. 1x cubed, negative 9x squared, 24x's, and minus 16. I like to put a 0 here. Subtract. 1 minus 0. Multiply, put that number up there. Subtract, get negative 10. Multiply, put that number up there. Subtract, get 34. Multiply by 1, put it up there. That's 34. When you subtract, you get negative 50. Now the question is, what did I do wrong? You're supposed to add. Well, let's look at a simple case. We know, for example, that x squared minus 4 is x minus 2 times x plus 2. Let's suppose we didn't know x plus 2. What makes this 0 is 2. So we have 1x squared, no x's, and the constant is negative 4. Maybe you add. Yeah, I guess you add. You add, you get 1. You multiply, you get 2. You add, you get 2. You multiply, you get 4 and 0. Yep, you add. Sorry about that. I never remember that, obviously. So, let us try this all over again. bit easier because now we're adding. Okay, like I said, I like to put it 0. 1 plus 0 is 1. And we keep multiplying by 1. That is, this number goes up there. You add, you get negative 8. You add, you get 16. You add, you get 6. Excuse me, 16 goes up there. You add, and the remainder is 0. So this is 1x squared minus 8x plus 16. That's the other factor. That's the other factor. X squared minus 8x plus 16. X minus 1. Now since this is x squared and not 3x squared, we'll play the x followed by number game times x followed by number game. I want two numbers that multiply out to 16 but add up to negative 8. And the two numbers are negative 4 and negative 4. Okay, that is what we get when we factor this first derivative. Times 4. There's the 4. When I factor what's in the brackets, I get this. I get x minus 1 times x minus 4 squared. Okay, and a lot of this stuff I'm going to call side work, and I'm going to erase it. On the side, we factor it. We use instead of division and all sorts of things. Okay, so let's see in terms of our numbering what's going on. Okay, the last two lines we're factoring. The third one is defined as 0. This equals 0 when, well, this factor is not 0. This factor is 0 when x is 1. And this factor is 0 when x is 4. The next step, oh, I guess there's 10 steps, not 8. The next step is to find the corresponding y values. And I'll just give you those. It's negative 27 when x is 1, and when x is 4, you get 0. You plug 4 in, you get the number 0. So now we go on and we do the same 4 steps for the second derivative. Okay, the second derivative, fine. I will take it from here because the 4 is factored out. So it's 3x squared minus 18x plus 24. Now I can factor out a 3 from that. 4 times 3 is 12. So I get x squared minus 6x plus 8. 12 times, so these two steps are the factoring, 2 prime. That prime has nothing to do with derivatives, please. Okay, so since it's x squared and not 7x squared, we'll play the x followed by number game. Want two numbers that multiply out to 8, they add up to negative 6. The only numbers now, numbers that add up to 8, if you use two positive numbers, two numbers that multiply out to 8. If they're both positive, then they have no chance of adding up to 6. So we're going to try negative numbers, like negative 1 and negative 8, negative 2 and negative 4, negative 3 doesn't go into 8, negative 4 does, but I have it already. Oh, those numbers add up to negative 6. So it's x minus 2 times x minus 4. That is step 2 prime. The next step, 3 prime, is to find the corresponding y value. Excuse me. To find out when the second derivative equals 0. Let's do that up here. coincidentally, when x is 4, we know what y is. It's 0. When x is 2, let's see what we get. You get negative 16. When x is 2, you get a y is negative 16. So that was for finding the y values. Now, step 5 was to find intercept. When x is 0, y is 0. Okay, because each term in the y formula has an x. You keep multiplying by 0 to a power, you're going to get 0. The next thing is to go to 3 and 3 prime and to write down all the x values that came up. 1 and 4 and 2 and 4. There's no need to write down repeats. 1, 4, and 2. 1, 4, and 2. In order, that's 1, 2, 4. And now we make up our table. We go from negative infinity to 1, and then we go from 1 to 2, 2 to 4, 4 to infinity. Then we go get a new marker. Hold on a moment, please. And we look at the plus minus signs of y prime and y double prime. It's just so I can see on my physical whiteboard better when we do this. So now, to get y prime, we have to look here where we have those 3 factors. Well, 4 is always positive. 4 is always positive. X minus 1 is positive when we're more than 1. Well, these 3 intervals, x's are more than 1. The first interval is negative. The last factor is being squared. Oh, that's always positive. So, negative, positive, positive, positive. So, I see a sign change between the first 2 signs. First is decreasing, then increasing. We have a min at 1. We have a min when x is 1. That is, we have a min at 1 comma negative 27. Let's look at the second derivative. Right here, nice and fast. 12, always positive. Every time 12 is positive. X minus 2. If you're more than 2, you're positive. Well, that's in the last 2 intervals. Always positive. The first 2 intervals, it's negative. X minus 4. That's positive when x is more than 4. That's just in the last interval. The last interval is positive. The first 3 are not. They're negative. Overall, it's plus, plus, negative, positive. We have a sign change here. That is, we have a point of inflection at 2. We have a sign change from negative to positive. We have a point of inflection at 4. Okay. So, I want to be careful about what I want to save. We're definitely not going to touch the table. That's our Bible. Well, I need the fact that we have 1, negative 27 is 1 point, right here. And 4, 0 is another point right there. And 216 is yet a third point, but it was negative 16. And 4, 0 I already wrote down. Okay. We erase most of this. Try to erase most of this. points that came up. Negative 9, negative 18, negative 27, and 4, 0. 1, 2, 3, 4, 5. So here's 4, 0. 2, negative 16, negative 9, negative 18. So here's maybe negative 16. 2, negative 16, and 1, negative 27. That's right here. All right, and this must be wrong. It must be 0 for us. That's a typo on the typo. Okay, the original function. Actually, 4, 0 did come up, but it turns out the y-intercept was 0, 0. It turned out that the y-intercept was 0, 0. Possibly we didn't even do that. We should have. Okay, so we have 0, 4. No, 4, 0 without change. And the y-intercept is 0, 0. We definitely should know where we cross the y-axis. And now we basically look at the graph. To the left of negative 1, the slopes are all negative. To the left of 1, the slopes are all negative. It's decreasing. It's decreasing. It's decreasing. To the right, between 1 and 2, it's increasing. Between 1 and 2, it's increasing. Between 2 and 4, it's increasing. Beyond 4, it's still increasing. Okay. Now we look at the second derivative. Gives us the flavor. Between negative infinity and 0 is concave up. Between negative infinity and 1 is concave up. That means it goes like that. Between 1 and 2, it's still concave up. That means it goes like that. Between 2 and 4, it's concave down. That means it goes like that. Beyond 4, it's concave up. So it goes like that. And there's your graph. Point of inflection here and here. Why? Because there's a sign change in the second derivative at 2 and another sign change at 4. Wherever the second derivative changes signs, bingo, point of inflection. Okay, that's the fourth degree. So let's try to do a cubic. Here's one. Suppose you were asked to graph y is equal to x cubed minus 3x squared plus 3. So y prime is 3x squared minus 6x. That's first step. Factor. You pull out 3x. You get x minus 2. 3x, get x minus 2, and the factoring is complete. Step 3, where does it equal 0? It equals 0 when this factor is 0, which happens at 0, or that factor is 0. That happens at get 2. 3 is never 0. Step 4 is to find the y value. When x is 0, you're going to get 3. When x is 2, you get 2 cubed, which is 8, minus 2 squared is 4 times 3 is 12, plus 3. I would do 8 plus 3 to get 11. 11 minus 12 is negative 1. So I found the y values for the x's in step 3. Now we do this all over again for the second derivative. Second derivative. Now, if you want, you might want to just come back and factor out the 3. So 3 times 2x minus 2. You can pull out, so now we're going to factor, okay, 2 common. We're going to factor out the 2 times the 3 that's already there, we get 6, times x minus 1. And 3 prime is to say this equals 0 when x is equal to 1. And 4 prime will be to find the y value when x is 1. And to find the y value, or to find out the valuation of a polynomial when x is 1, just deal with the coefficients. 1 minus 3 plus 3. If you have a number, whether it's 1 or not, and then you take away 3 and you add the 3 back, that cancels out. You just get 1. So y is 1. Okay, so we did the main 8 steps. The next step, I'll try not to skip this time. The next step is to find the y-intercept. If x is 0, y is that constant. Coincidentally, we have it right here. It came up already. One of the critical points was the y-intercept. Okay, so we did that. The next thing is to write down the x values that came up in step 3 and step 3 prime. I'll call that 6. 5 was already done. 0, 2, and 1. And we'll just put that in order. 0, 1, 2. Now we make up our table. We make up our table. I'll put the table down here. I think we have more space. Y prime, y double prime. And the intervals just have to skip those numbers. That is, here is 0, and here is 1. Let's make it bigger. Here's 1, and here's 2. You have from, okay, call that 0, excuse me. Try that again. The extreme left is reserved for negative infinity, and the extreme right is reserved for positive infinity. So like right here is negative infinity, and all the way to the right is positive infinity. Negative infinity, positive infinity. So I'll put 0, 1, and 2. The first interval is from negative infinity up to 0. And then from 0 up to 1. And then from 1 to 2. And then from 2 all the way to infinity. And we look at the first derivative, all factors, which is right here. 3x, x minus 2 are the factors. 3, always positive. X, only positive when we're more than 0. The 0's right here. So to the right of this line, I put positives. To the left, I put negatives. Positive, positive. And now, x minus 2. That's positive when x is more than 2. Well, there's 2. To the right of this line is more than 2. So I put positive. To the left, I put negative. For the first derivative, these are the overall signs. Second derivative. Second derivative is 6 times x minus 1. 6, always positive. X minus 1. X minus 1 is only positive when x is more than 1. That is to the right of 1. Here and here. Otherwise, it's negative. Negative concavity, negative concavity, positive concavity. So we have a change. We have our point of inflection at 1 and positive concavity. First derivative, positive slope, negative slope. We have our max at 0. Negative to negative, no sign change. It's negative and then it's positive. We have a min at 2. The table tells you everything. Okay, let us graph this. Okay, so what I wanted to say were the points that came up. I'll put them in big red. These 2 points and this point down here. From step 3 and 4, 3 gave us the x's, 4 gave us the y's, and 3 prime and 4 prime. In fact, let me put these over here. That way I can use more space. 0, 3, 2, negative 1. Okay, let's graph this, folks. X and y. You should look at the highest and lowest x and y values so you know how much space you can need. For example, x just has to go out to 2. Well, I can space them out. And the y's, they just go up to 3. 3, 2, 1, 0, negative 1, negative 2, negative 1, negative 2, etc. So 0, 3 came up. That's right here. 2, negative 1. That's right here. And 1, 1. That's right here. These are the points that came up. Okay. So I'm looking at y prime now. Between negative infinity and 0, we're increasing. So I'm increasing. Between 0 and 1, I am decreasing. Okay? I am decreasing. Between 1 and 2, I'm still decreasing. Okay? Still decreasing. From 2 on, I'm increasing. Between negative infinity all the way up to 1 is concave down. So here's my real graph. Concave down. Beyond 1, from 1 all the way up to positive infinity, I'm concave up. I'm concave up. Here's your graph. Okay. Now, I promise you that there's another way of doing cubics, and you kind of eat through these problems. Unfortunately, your teacher probably never seen this formula that I'm going to show you, but it still works. If you know that these are the two critical points, and there's the point of inflection, then you can draw your cubic every time. If these are the 3 points that came up, well, then your cubic goes like that. If you have the highest value, and if you have the high critical, the critical max, and the min, graph goes like that. And in the middle will be your point of inflection. So we're going to try to figure out what those points are. We want to get a formula to get those points. We'll even get a formula for the point of inflection. It's a lot of algebra. We do it one time. We remember the formula. It's actually an easy formula to remember because it looks like another formula we should have. Alright, the general equation of a cubic is a number times x cubed plus a number times x squared plus a number times x plus a constant. The first derivative is 3 times the number in front, x squared, plus 2 times the number in front, which is 2b, x, plus the constant. And the critical value is going to be when this equals 0. We want to set y prime equals 0. 3a x, and that is, I need to say 3a x squared plus 2bx plus c is 0. But this is a quadratic equation. And we have a nice formula for a quadratic equation. The number in front of x squared, that's the a value. The number in front of the x, that's the b value. And the constant is c, provided it equals 0 when it does. And remember, x is equal to negative b, and that's b, plus or minus the square root of b squared minus 4 times a times c, which is c. And all of this gets divided by 2 times a. A is 3. Big A is 3. So it's negative 2b plus or minus 2 squared times b squared minus 12. 4 times 3 is 12 times a times c. And all of this is over 6a. Negative 2b plus or minus. Now, under the radical, we can factor out a 4. 4 times b squared is 4b squared. 4 times negative 3ac is 12ac. And this is all over 6a. Let me come up right here, please. Negative 2b plus minus. Now remember, square root of one thing times another thing is the square root of the first times the square root of the second. That is, I can do the square root of 4 times the square root of b squared minus 4ac. Minus 3ac, excuse me. So we get minus 2b plus or minus the square root of 4 times the square root of b squared minus 3ac, and all of this is over 6a. But the square root of 4 is just 2. The square root of 4 is 2. Now, I can actually factor out a 2. 2 times negative b plus or minus b squared minus 3ac. I factored out the 2. And all of this is divided by 6a. Now, 2 goes into 6 3 times. Negative b plus or minus the square root of b squared minus 4ac over 3a. Now, there's a reason why I remember this formula. Oh, yeah. Over 3ac. There's a reason I remember this formula. And here's the reason why I can remember this without having to derive it each and every time. One second, please. The quadratic formula looks like this. X is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. The only real numbers I see are 4 and 2. What's in between 4 and 2? 3. Notice in those same two locations that I circled on the top right are where the 3's are in my formula. This is the formula that gives you the two critical values of a cubic. Okay, let's erase this up here. It really doesn't belong there. Okay, so there's a nice way of remembering the formula. Instead of 4 and 2, you have 3. Okay, now to find, so now we want to find the second derivative and see when it equals 0. If we're doing those same steps that we did before, except now we're doing it one time and one time only. This is it. Here it is. This is the one time we're doing it, and then we just use the formula. Then we just use the formula, and we never have to do what I'm doing now. You don't understand it, you don't want to understand it, not a big deal. Know how to use it. On the bottom right is the formula. Now what I want to do is take the second derivative. I want to take the second derivative. I have the first derivative. Oh, it's actually on the line above. I have the first derivative. Now I want to find the second derivative. And see, when it equals 0, y double prime is 6ax plus 2b. And I want to set this equal to 0. Bring this to the other side. I get 6ax is equal to negative 2b. Then I divide by 6a, divide by 6a, and I get x equals negative b over 3a. Because 2 goes into 2 one time, and 2 goes into 3 3 times. Okay, this is the formula for the point of inflection. Okay. Now, this is where I put all the pieces together. I'm going to use these two formulas to do a cubic graph. I'm going to use it to graph a cubic equation. Y is equal to x cubed minus 3x squared plus 3. We're going to use it to graph the same cubic that we just did. The only thing is that we need to have, so that a is 1, that b is what's in front of x squared, that c is what's in front of x. Since there is no x, we can always add 0. 0x is 0 plus 3. The a is 1, b is negative 3, and c is 0. So to find the x value of the max and min, it's negative b I'm using this formula down here, plus or minus b squared, negative 3 squared, minus 3 times a, which is 1, times our c, which is 0. And all of this is divided by 3 times a, which is 1. So I get 3 plus or minus the square root of 9 minus 0 over 3. So I get 3 plus or minus the square root of 9 is 3. So I can have 3 plus 3 over 3, which is 2, or 3 minus 3 over 3, which is 0 over 3, which is 0. So I found the two x values. And if you plug in 0, out comes 3. And if you plug in 2, you get 11 minus, you get negative 1, just like before. Plug in 2 here, get negative 1. Plug 2 in, get negative 1. Plug 0 in, get 3. Okay, now for the point of inflection. Here's that formula. The x value is negative b. b is negative 3 over 3 times a is 1. We get 3 over 3, which is 1. And when x is 1, we get 1, right? We get 1. Okay, so those are our key points. This is point of inflection. Every cubic has a point of inflection. And generally, they have maxes and mins. Since 3 is the largest, that's the max, and that's the min. And I never took a derivative. I just used this formula. I took the derivative one time, I came up with my formula, and that's it. Now, why does it work so nicely with cubics? And the reason is when you take the derivative of a cubic, you get a quadratic equation. It goes down 1 degree. And we have a formula for a quadratic equation. Now, if you have a 4th degree polynomial, when you take the derivative, it becomes a cubic. And we actually have a formula defined as zeros over cubic, except it's not the friendliest formula. In fact, I don't even know what the formula is. I've seen it once or twice. I never bothered to use it. It's insanely complicated. Alright, so let's just graph this and that's it. 1, 1, 1, 1. That's my point of inflection. 2, negative 1. That's my min. And 0, 3 is my max. Okay, there it is. There it is. Never took a derivative. Alright, go over this stuff. It's doable. Good luck with it.